In this video, we're going to briefly review what I mean by an assembly. I'm going to show you how you can break up an existing program into libraries, and how we can modify assembly attributes, and what the internal accessibility modifier means. So let's remind ourselves what an assembly is. An assembly is the smallest unit of shippable code in .NET. It's a bunch of code that has its own version. It can describe the types that are in it. And the executable files that we've been building so far are all assemblies. Right? They are bits of code that we could ship to a customer if we wanted to. But the code that's in libraries that we've been using, the stuff that's in the system and all the collections and all of that stuff, those libraries of code that we've been using are also assemblies. They can also be independently versioned and independently shipped. So let's take our Hangman code. It seems like it's a good candidate to be put into a library. So if we go into Visual Studio here, you can see what I've done is I've created a project here. And this solution has two projects in it. It's got a project called Games, and it's got a project that's unimaginatively called Video 26. So in this solution, Video 26 is the console application. It's an executable, and that's an assembly. And it depends upon the Games library that I've created here. So you'll notice that in the Games project, there's the Hangman code, there's the outcome code, there's the player code. And in the Video 26 project, we're now down to just the program class. All right, so what changes have I made to the Hangman code? I've made a few changes. They've all been pretty minor. The first one is that I have made a namespace. We haven't talked too much about namespaces. We've talked about using namespaces in using directives, where we say, well, there's a bunch of types in this namespace, and I would like to not have to type system.collections.generic.list. I just want to type list. So the using directive does that. But we have namespaces in order to organize our code, make it easier to find code. And it's a good idea if you're writing code in a library to have a namespace. And often the name of the namespace is the same as the name of the library. Now, we don't ever want to end up in a situation where we have a namespace called Hangman, and there's a class called Hangman in it. That is legal. You'll notice we're not getting any red squigglies here or anything like that. But it's a really bad idea, and the .NET programming guidelines strongly discourage you from doing that, because it is possible to end up in a situation where the compiler can get very confused about whether you are talking about the Hangman namespace or the Hangman type within that namespace. And then people end up sending me questions off of the internet saying, why doesn't my code compile? I can't figure this out. Just don't go there. Remember, the idea of a namespace is to organize a big bunch of code. And so you should be able to find something that is in common to that big bunch of code. Right? So in this case, we've got a library. Let's suppose that the library is going to be for a bunch of different games, not just Hangman. So I'm going to create a namespace called Games and then put my classes in that. Now, if you were writing code for some much larger organization, then they will probably have a policy about what their namespace names should be. And very typically, you'll see namespaces where it's the name of the company first, and then the name of a division within the company, and then the actual business purpose of this code. Right? So you might see, foocorporation.accounting.utility code, for example. All right. So anyway, all I've really done here is I've created a new library project. I did that by just clicking on the solution and selecting Add. And then here I chose from the list of possibilities, I chose class library. Well, I chose one of these class libraries. There's a bunch of different ones. There it is, class library there. And created a new project, moved the code into it. It was pretty straightforward. So now we have this library, and we still have this code here that depends on the code in that library. So we should be able to just build this. So let's build it and see what happens. And we got a bunch of errors. And if we go take a look at the errors here, we can see that in our program, everywhere that we have used the type Hangman, it is now red squigglying and saying, oh, I don't know what that type is. Now, the error message here is the type or namespace name hangman could not be found. OK, so first of all, you note that the error message says, I can't figure out even whether you meant this to be a type or a namespace name. But either way, I don't know what this means. It could not be found. OK, that's good information. Now, the parenthetical is actually the most important part. It says, are you missing a using directive or an assembly reference? You would be astonished by the number of times people send me a question that says, my program won't compile. I can't figure out why. I'm getting this error message that says, are you missing a using directive or assembly reference? And I ask them, are you missing a using directive? And they say, oh, yes, I am. Well, you didn't actually have to ask me the question. You could have just read the error message, right? That's telling you that you're probably missing a using directive or an assembly reference. So let's recall what I mean by assembly references. When one bit of code needs to talk to code that's in another library, you have to tell Visual Studio that fact. And that is in this list of references down here. So if we look down this list of references, this is saying, OK, well, this code is referencing Microsoft.C# and the system code and the data code. And it's actually not using all of these references, but these are added by Visual Studio because these are the most commonly used ones. So what I need to do here is right-click on this thing, say Add Reference. It pops up this dialog box. Go to the section that says Projects. And then I say, this code is going to reference the games project. Click on that little box. Hit OK. All right, so now we're good, right? We have solved the problem. This project is now referencing this project. And so we should be able to build this. And once again, we get the same error. Well, what's it say? Are you missing a using directive or an assembly reference? Well, we know we're not missing an assembly reference, but we are missing a using directive, using games. All right, so now this code should finally work. All right, so now we're getting an error message that says that it cannot access Hangman because of its protection level. Well, what's up with that? Well, you remember how I said that in C#, everything that you create is treated as, every member that you create in a class is treated as private unless you say otherwise, unless you say it's public or it's protected. There is another accessibility modifier that I've mentioned a couple of times, which is called internal. And internal means this code is accessible only within this assembly, right? So it's sort of like private, except that it's private to just the assembly and cannot be used outside of that assembly. Now, classes are in C# by default, if they're top-level classes, they are internal by default. So we don't have to say internal here. It's just assumed. If we want this thing to be public, if we want it to be used outside, then we have to say that it's public here. All right, so this has solved the problem here. So let's rebuild this. And we're still getting errors. What's going on here? Well, now we're getting a red squiggly here saying inconsistent accessibility. Parameter type player is less accessible than the Hangman constructor. So what's going on there? We forgot to make the player type public. So our code is now wrong in two ways. First, we have the other assembly, video 26, is still accessing the player class, and it can't do so because it's internal. Also, the C# compiler is noticing this is a public constructor, but it requires that you pass in an instance of a type that is internal to this assembly. And therefore, this constructor could only be used from within this assembly. So why is it marked as public? So it's informing you that something looks wrong here, and I'm not going to let you keep on doing this. You have to make sure that all of the types that are used in a public method are visible to the code that the public method is visible to. All right, so let's go over to our player class. We'll make that public. We'll go over to our enum. I've already made that one public. And now, finally, we should be able to build this. And it succeeded. OK, so now our program compiles. I want to talk a little bit about assembly attributes while we're talking about assemblies. If we drop down this little properties thing here, you'll notice that there's one for games, and there's one down here as well for video 26. And both of them contain a C# file called assemblyinfo.cs. And if we take a look at this thing, we can see that all it consists of is a bunch of attributes. And you recall earlier I said there's a syntax for attributes, which always appear in square brackets. And they usually appear attached to an enum, so that you can say flags. We'll see some examples later where there are attributes attached to classes and methods. The way you attach an attribute to an assembly is you just write an attribute, and you just start it with the word assembly and then a colon. And these attributes allow you to specify things that are of interest to people who might be looking at this assembly, trying to figure out who wrote it, how it works, all that kind of thing. So you can say the title and the description and what company made it and what the name of the product was and what the copyright date was. So before you ship an assembly off to customers, probably a good idea to just look in here, make sure that all of this stuff is the way you want it. So summing up this episode, library assemblies are a useful mechanism for putting a bunch of related code into one redistributable package that you can then use in several different programs. You can use namespaces when writing a library. You probably should. Typically, the namespace name would reflect the name of the library. And you can use the internal accessibility modifier to make a member or a class that is accessible only within code in a given assembly. So it's public within that assembly. It's private to code outside the assembly. And you should make sure that you mark all of the classes and enums and everything else that you need to be public in a library assembly as public, because otherwise they'll be internal by default.